Let us carry on grade 12s. I've just erased the work that I've done here just to get a little bit of a space. We have determined the y-intercept. We have also determined the x-intercept. So remember, the second step is to find what? Is to find the stationary point or the turning point. So to find the turning point of a cubic function, our function is f at x is equals to minus x cubed plus 5x squared plus 8x minus 12, which is a cubic function. So to find the turning point of a cubic function, we use the first derivative. Why do we use the first derivative? Is because remember that the first derivative, it gives you what? In fact, the derivative, it gives you what? It gives you the rate of change of a function at a point. It also gives you the gradient of a tangent to a function at a point. So in this case, we'll be using the derivative to find what? To find the rate of change of a function at a point. Remember the turning point. The turning point here, why do we say it is the rate of change of a function? Is because it changes the function from a decreasing function to an increasing function, or rather it changes a function from an increasing function to a decreasing function. Hence we say the derivative, it gives you what? Gives you the rate of change of a function at a point. So in this case, we are going to use the derivative to find what? To find the rate of change of a function at a point, which is the turning point, of course, which is the turning point. So in other words, we are going to have f prime x is equals to, we differentiate that using the power rule, minus 3x squared plus 10x plus 8. That is the derivative. Now they say to us the turning point, at the turning point, f prime x has to be equals to what? Has to be equals to 0. And f prime x is what? Minus 3x squared plus 10x plus 8. So in other words, minus 3x squared plus 10x plus 8 has to be equals to what? It has to be equals to 0, because the turning point, at the turning point, f prime x is equals to 0. We are going to solve for x here. We divide this by minus 1, divide by minus 1, so as to make the coefficient of x squared positive. So you're going to get a positive 3x squared. This one will be minus 10x, this one will be minus 8. Is equals to what? Is equals to 0. Then we solve for x. If you don't know how to factorize, remember you can use what? Remember you can use a quadratic formula to solve for x in this question. So we're going to have 3x plus 2. We're going to have x minus what? Minus 4. So we have 3x plus 2 is equals to 0, or x minus 4 is equals to 0. So x is equals to what? X is equals to positive 4. This positive 4, it is the x value of what? The x value of the turning point. Let us find the second one. X is equals to minus 2 all over 3. This value of x, it is the second x value of what? Of the turning point. So that simply means we're going to have two turning points. So we take these values and substitute them to the original function, to get what? To get the corresponding y values. So we're going to have f at minus 2 over 3 being equals to minus into what? Minus 2 over 3 cubed plus 5 into minus 2 over 3 all squared plus 8 into minus 2 over 3 minus 12. So how much do we get there? I think you should get minus 14.81. Minus 14.81. We find the second corresponding y value, f at positive 4, which is equals to minus into 4 cubed plus 5 into 4 squared plus 8 into 4 minus 12. Well, you should be getting positive 30, positive 36. Positive 36. So in other words, our turning points, let me write it up there. Our turning points, we have one. we have minus 2 over 3 is to minus 14.81. That is the first turning point. And what? Positive 4 is to positive 36. That is the second turning point. That is the second turning point. Now, going back to our holy cross now. Now we can sketch. We have the x-intercept and the y-intercept. We also have the stationary points. So the last step is to sketch the function. I'm going to start with the x-intercept. The first x-intercept here, we have minus 2 is to 0. The second one here, we have positive 1 is to 0. The third one, we have positive 6 is to 0. I'm going to also plot my y-intercept. I have 0 is to minus 12. 0 is to minus 12. 0 is to minus 12. Here I have minus 2 is to 0, which is my x-intercept. I also have what now? I also have 1 is to 0, which is my second x-intercept. I also have what? I also have 6 is to 0, which is my third x-intercept. Now I'm going to plot my turning points now. The turning points to see which one is the maximum turning point and which one is the lowest turning point. Well, you check your corresponding y values. Check your corresponding y values. The greater corresponding y values, it shows that turning point is what is the maximum turning point. And the smallest turning point, it shows what? The smallest y between these two y values, it simply means it shows that turning point is the minimum turning point. Since well this value of y is greater than this one, that simply means that this one, we have what? We have the maximum turning point. And for this one, we have what? We have the minimum turning point. We have the minimum turning point. To see which one is greater between these turning points, just check your values of y. They will tell you which one is the maximum turning point and which one is the minimum turning point. So this is the maximum turning point. That simply means it will be somewhere there. 4 is to 36. This is the minimum turning point. That simply means it will be somewhere there, where we have a minus 14.81. Minus 14.81. It corresponds with it should correspond with minus 2 is to 3. So it should be somewhere there. Minus 2 over 3 is to minus 14.81. Those are my turning points. And now I'm going to join them. This is the turning point. It is going to touch there. It is going to touch there. My x-intercept. This is my turning point. Joining it with my x-intercept. And there it is, grade 12s. Remember, when sketching a cubic function, you must first find what? X-intercept and y-intercept. And to find the x-intercept, please use the table that I've used. If you have any problem, you can contact me via WhatsApp or via the email. Use the table that I've used, or you can use the long division method. If you are very comfortable with the long division method, then you can use the long division method. If you are not, then please use that table that I've used. The second step is to find what? Is to find the stationary points or the turning points. And the last step, of course, will be to sketch your function.